All right, so I think I'm recording. Let's take a look here at this problem, number one. We have a polynomial function of degree 3. The leading coefficient is 1, and that's positive. The degree is odd. So since it's a positive leading coefficient, it's going up to the right. Since the degree is odd, it's in opposite directions. So as x goes to negative infinity, so does y. And as x goes to positive infinity, so there's one, yeah, so it's the case 3 there. If you evaluate this function at 0, we get the y-intercept. That y-intercept has coordinates of 0, -6. Now, soon we're going to be looking at a theorem that is referred to as the rational zero theorem. It uses the factors of the leading coefficient and the factors of the constant term to generate a list of numbers that may or may not be x zeros of the function, x-intercepts. It's the only thing that we really have. It's not all that powerful in the sense that it will not find x-intercepts that are irrational numbers, like a square root of 2. So it's possible that you could go through the whole list in search of a zero remainder and not find one. So there's no guarantee that any of these numbers are an actual x-intercept, an actual zero of this function. So we more or less just have to jump in and start trying. So there's 8 possibilities here, and I don't have a suggestion as to what to try. We can do it one of 2 ways. We could just plug in and do the arithmetic, and sometimes maybe that's easier than the synthetic division, but when we do find a 0, we'll want to do synthetic division. So let's illustrate that. Let's go ahead and plug in 1 and see what we have. We would have 1 cubed, 2 times 1 squared, and you can see that that's clearly not equal to 0. What about if we tried -1? We'd have -1 plus 2 plus 5 minus 6, and that does equal 0. So had we done our synthetic division, we get our 0. So you might ask, well, why do we have to use the synthetic division? Well, we have to use the synthetic division because evaluating it did tell us it was 0, just like the synthetic division told us it was 0, but it's this result right here that helps us to factor this polynomial. So this polynomial that started out being x cubed plus 2x squared minus 5x minus 6 can now be factored to x plus 1 times x squared plus x minus 6. If we set this equal to 0 and continue factoring it, in factored form, this is what we get. Well, we can then construct a table. A table is just a nice organized way to present this information. I guess it doesn't have to be a table, but -1, -3, +2. The multiplicity of each factor is 1. Since those are all odd numbers, we know how the graph intersects the x-axis is that it crosses over it. There is a fundamental theorem of algebra that tells us if you have a polynomial, and it does say something about the coefficients. I think it has to have real coefficients that if it's of degree 3, then it has maximum 3 zeros. Now, of course, we've seen that some of those zeros could have a high multiplicity, could be a repeated zero, but we have found all the zeros. We know that there's not a fourth zero there. We have found all of them. All right, so I hope this helps, and I'll talk to you later. Bye.